Good morning, good afternoon, good evening, wherever you are. Welcome to our SUSECon digital session, SUSE High Availability for SAP Workloads. My name is Fabian Herschel. I'm the principal architect for SUSE working in the SAP Linux Lab, and I am responsible for HA solutions for SAP Workloads.
Hello from my side. My name is Lars Pinne. I'm also with SUSE. I've spent several years working for SUSE in the field, and now I'm working with Fabian in the team at Waldorf. Yeah, today we will talk about SUSE high availability for SAP workloads. That's a broad area. What will we talk about? So first we will give you an overview on already well-known and supported scenarios. Then we will shortly highlight what scenarios we will cover today. And then in the main part of this session, we will discuss three aspects of high availability for SAP HANA. The main focus is scale-out systems. We will discuss scale-out for ERP systems. It's a special case. Then we will discuss scale-out multi-target replication. This is something new. And at the end, we will give a short outlook on what might come in the future. And at the very end, then we will provide you a short overview and a summary that you can take with you to know what you want to do next.
First station, introduction. So we have here a list of scenarios we are currently supporting or having under research or under testing. We can differ from scale up, which means a box scaling up in memory, and scale out means setting multiple boxes side by side, building together one HANA database system. I want to focus on the HANA performance optimized scenario first. It's the most implemented one together with performance optimized with the secondary side being read enabled, where customers have decided that they want to use the second system, which is just waiting for the takeover for at least some workloads. And then you can load balance, can report some things on the secondary side. And so the load on the primary side, which needs to run the database changes, decreases. The cost optimized thing, is where you have on the secondary side another system, not under system under system replication, which is running till the takeover occurs, and this one would be shut down. Those scenarios are already supported with our packages. Then the next group is the multi-tier and multi-target things. For scale up, it's already supported in the shipped packages, but only two sites are inside of the cluster. The third one, like disaster recovery, is outside of the cluster. For scale out, also we concentrate on performance optimized scenarios, and here we are supporting things with enabled SAP HANA HA, having standby nodes which could take over a lost name server node or a lost worker node. And we can even do it also with scenarios where you do not want to have this SAP HA enabled and you do not have standby nodes. For example, we'll say later ERP systems are typically built that way because they need very big systems. So all those scenarios are typically supported. What we are currently doing for SAP 15 SP3 is adding also the support for multi-target replication with two sites in the cluster and the third site out of the cluster.
Yeah, thank you, Fabian, for the overview on supported and upcoming scenarios. As mentioned, we will now look into two of those scenarios in more detail. First, we will describe how scale-up ERP system should be set up for making it high available with SUSE HA, and then we will discuss how you can add DR, disaster recovery functionality, to this HANA HA system. And at the end, we will give an outlook on better integration between the SAP management tools and the HA cluster, because the more clusters are in use, the more the people have to know how to work with that systems in day-to-day operations.
Second station is Destination HANA, and now we go to the detailed scenarios.
Thank you, Fabian. We have decided to do this presentation with different roles. My role is to present the challenge or the problem. So I'm the problem maker, troublemaker, and Fabian then has a job to solve the situation and to describe how a solution looks like. So coming to the first challenge, HANA scale-out systems for ERP systems. In the very beginning, scale-out systems usually have been set up for analytical workload, for BW installations, but over the time, the systems that have been brought on Linux were bigger and bigger, and now some customers are already reaching limits of virtual machines or even of physical machines. So if you have a system that is bigger than, say, 20 terabyte of data, then you need to think about how to run it. And for that cases, SAP agrees in splitting an ERP system into two fractions. And this means you run two Linux systems with two HANA databases, but the two HANA databases form one logical large system. And if you want to have high availability, of course, then you have to put this under control of a Linux cluster. Since these are very large systems, start and stop can take more than an hour. If something goes wrong with certain processes, like the index server, even shutdown of this defunctional process might take an hour. We also have seen that HANA does not react very well on certain kinds of failure. For example, if the shared NFS file system for HANA shared got lost, then the cluster might not see any information from HANA about this problem. Since these systems are that large, customers tend to not spend money for additional standby nodes. This is different to usual scale-out systems. Many customers want to use the second site for kind of reporting, so they need to set up the active read-enabled feature of SAP HANA, and the cluster then has to control a second IP address. And at the end, the most important thing, even if this is a relatively small setup compared to the large BW systems, the SLAs are very tight, and it's very important to keep this in mind when you design the whole solution. So this is a challenge, and now let's see what Fabian has to say for this as a solution.
Yeah, thanks, Lars, for summarizing the challenge and explaining what are the things we need to solve here. So for ERP systems, as already said, we typically only configure one master name server. We will say later on how we will do that, or how you can do that in SAP. The idea behind is because those machines, Lars said it already, they are very expensive. And if you want to take over and have a standby node in addition, the entire system would be very expensive. So our solution now needs to be capable that the SAP HA is being turned off. There's no takeover inside. And so the cluster must detect that correctly, not waiting for SAP HANA failover inside. And if a primary site goes down, immediately initiates the takeover to the secondary side. We have two resource agents, SAP HANA Controller, which is doing how the name says, the control of the HANA, so doing the start, the stop, the detailed monitoring of healthness, and the SAP HANA Topology resource agent, which focus a bit more on all cluster nodes, looking if any HANA is being configured there, which site is it, and so on. So getting more the topology of your rolled out system. You can, all our scenarios we said before, you can already use with the current packages. You should have a very new package if you want to have an adaptive start stop timeout. Then you can adjust in the cluster settings how long the system is expected to as longest for a startup or shutdown. So typically we have learned that SAP HANA systems at the beginning were a bit slower to start up. Then they got very fast. So we said less than 1 hour is enough. But now the systems are growing again. And in some kinds, the start timeout raised our maximum. And now you can configure that with the newest packages. The H8 provider hook as a server state change. It's a call out of the HANA system calling a Python script. You can use that for a fast shutdown. If, for example, on the worker nodes, the HANA index server is dying, and this could take very long because if it is dying, it needs to free all the memory. And so if you want to have the HANA been going faster down in such a situation, so the cluster could do and process the takeover, then you implement such a hook, which detects from HANA inside that such an error is secured. And in the hook, we decide when we're taking down the HANA completely and faster, not waiting for each process to recover. You can have optional location constraints for the IP address if you want to have a read-enabled ERP side on the secondary side. I already explained that this is something like also load balancing, having read-only queries at the secondary side, getting the load on the primary side decreased. So, and with that, I come to the HANA data and logs. The lucky thing here is that we do not have a standby node because lucky here is that we do not need a shared disk infrastructure to access the data and logs because each node has exactly one segment and then can attach to his data and his logs. And so you can build up such workloads much more easy from the hardware or from the cloud perspectives. And so you also do not need a certified storage API, which needs to implement and to guarantee storage fencing. We have one system which needs to be shared, so we are not completely shared nothing, but at least the good thing is you can place that on NFS because there's not such a high traffic. It's HANA shared, and there typically you have the configuration files, you have things which are related to the entire HANA system, but there's not so much data traffic on that. But this is also a critical point. You need to have high available because if this one crashes, you do not have access anymore to the binaries of a HANA, which also could influence the cluster functionality. Here we have 5 nodes in our cluster, so 2 sites with 2 disks each, and in the middle the MM is a majority maker node, which builds the quorum if one side goes down completely. And we have the fencing symbol here in our cluster. Fencing is essential for the cluster because you need to guarantee if nodes get lost that they are really not running any resources. So there's no misreporting. And the cluster can surely take over resource and can guarantee that it's only running one time. So you can do that with diskless or disk-based SPD. Diskless is valid for clusters beginning from 3 nodes upwards. If you are using disk-based SPD, you should do it with 3 devices to have the best high availability. Coming to the pretty details, at the left side, you see where we define a primitive for the read-only address. So for the secondary side, we build a co-location which builds it to the slave status. And the interesting thing, the location, which binds to the attributes written by SAP HANA topology, and where you bind to the master name server of a secondary site. So these 2 rules are guaranteeing that it's not running on the primary, and the second one is guaranteeing that it's not running on a worker node. So those 2 are combined, placing the IP address correctly. On the right side, you see how we configure the landscape to have exactly one master name server node. You see that we have just one entry as master and also as active master, and the other rules are worker node. So you have one node which is master or master name server candidate, and worker if it is started, and the other one is slave for the name server, and has also a worker node, is also the worker role for the index server. Or you can see also how SAP is recommending to deactivate SAP HA if a cluster is running, and there are some problems in the interfaces. Here we are not focusing on problems, but on the special way how ERP systems are being set up. But anyway, you get this information also from SAP.
Yeah, thank you, Fabian, for solving the first challenge. Now I have another one for you. Once you have set up your scale-out ERP system with SUSE cluster across 2 sites, then you will find out you need a DR site for the really great disasters. This is one use case, and another use case, not that spectacular, is you want to copy over the data from your production system to your performance system or to your test system. And in both cases, you need to add a third HANA database by system replication to your running production cluster, as Fabian mentioned in the beginning. Until now, this is not possible for scale out, because the resource agent does not contain code for detecting different system replication links. So the challenge here is we have to make sure that a running HA cluster with HANA scale out systems can handle another system replication to HANA outside the cluster. This is a challenge. Let's see what Fabian can tell us about that.
Let's see, maybe I have something. So for first, beginning with our scale-out solution, we already had an implementation of a hook which was detecting changes in the system replication status. So the HANA was immediately telling the cluster that something is going wrong in the system replication at a glance. Beginning from SAP HANA 2.0 SPSO3, we now have an interface where this call out also gives us the remote site to which the system replication has a status change. So now we are able to differ immediately in the immediate call if the system replication is going down in our example for site 2 or for site 3. And so we have moved the formerly global attribute as a hook from the global space to the site space, and which is this is what we are planning for a release of SAP HANA SR Scale Out 0.180, and this is planned for SAP 15SP free. This is not really backward compatible. This is why we are having a migration procedure for that. So the new resource agent could drive your old cluster, but if you set it up and go to the new version, you should not go back to the old resource agent. So it's just like a migration to a new world, which gives you more features. If you would stay with two sites, you do not need to do anything, because then the global attribute is sufficient as well as the site attribute. But if you want to implement this, Lars has shown it as this free sites multi-target thing, where one site is replicating to two others. Or you have a chain. You can even configure your HANA systems that they attach register automatically if the primary changes from a primary to a new primary. So the standby gets promoted, and then the third site could register automatically to this new primary. So it follows those decisions, so you don't get lost. The DR or the temporarily syncing site. So this is much more better as we had it in forehand. Yeah. With that.
Okay, thank you, Fabian, for answering the second question. I have one more. So once you have running your cluster with HANA scale out and multi-target replication for a while, then you need to do some administration on the cluster, maybe a software update or whatsoever. And in general, with HA for HANA, you always have the two distinct universes. You have the Linux and HA, SUSE HA world, and you have the HANA and SAP world. Both worlds have their own tools. Unfortunately, for the HANA workload, the two worlds are not that well connected. So basically, you can do whatever you want with your HANA cockpit, and HANA cockpit will then touch the HANA and, for example, do an SR takeover, but the cluster is not aware of your intention, and for the cluster it looks like a problem. The cluster then will jump in and do something, and in worst case you will end up with a split brain situation where you have two primary databases, and this is something you never want to see. And so we need to improve the interfaces between the SUSE cluster and the SAP tools to get rid of this situation. And this is what we are working on at the moment. And Fabian can give us an outlook, what you can expect.
Thank you for this third challenge. Wow. So yeah, we have luckily another HRDR provider hook method for this. It's called pre-takeover. And the name says that it is called before the takeover is being processed. And we are using this this hook method in an own SUSE designed hook to interact with a pacemaker cluster. And this gives us the chance to differ if the admin is running the takeover command while the cluster will do the complete control of the SAP HANA system replication pair, then it needs to decline it. Or if the cluster itself is running this takeover command because something is going wrong on the primary side. And of course, then the takeover must be passed. Yeah. How we are doing that? During the operation of a resource agent, once it wants to trigger a takeover, it sets a special cluster attribute. And our hook is then interacting with the cluster, asking, is the resource agent in itself in the process of a takeover? And if so, I can pass that through and can allow it. If the admin is doing it, it will be declined. Now you would say, maybe I want to do takeover manually and I really know what I'm doing. Then it's a good thing to set the cluster better, the multi-state resource control SAP HANA controller to maintenance. So there's no running monitor. Then our hook detects that and says, okay, the cluster is in place, but it's not currently managing the SAP HANA resource. So I can bypass this takeover. So now the admin is really into the account of guaranteeing that the other side is being done. So you can even in such a case doing things like a maintenance update of the two HANA sites. If you are setting that to maintenance, then even seamlessly the IP address will be taken over. And so here you can do that with a takeover whenever you would doing down of a primary in the maintenance, running as an admin a takeover command, then the IP address for the access of the HANA system on the primary side will move to the new primary. So this is all integrated in this solution. And as you can see, it's an architectural painting. So this is still in the process. We have already a preview in our SUSECON demo 1192. If you want to have more details, and the good thing for you is that this works with any SAP client tool. So if you are using SAP HANA Cockpit, the graphical one, if you're using command line, they are all covered in that way. So third station is now conclusion.
Yeah, if you are interested in learning more, in going deeper into the details, maybe if you are already planning a scale-out HA cluster, then we have, of course, lots of details, concepts, parameters, examples shipped with the product in the good old man page format. And of course, we have our web pages with the product documentation for general questions like how to set up SPD fencing. And we have ongoing blog towards zero downtime. We have the support articles for special topics. We have our SUSECON archives for this year and the last years. There's a lot of sessions about HA and SAP. We have a dedicated space for setup guides for specific scenarios. So basically the scenarios Fabian has shown in the very beginning are covered by dedicated setup guides. And of course, we have services available for training and consulting as well. Now coming to the very end, to the conclusion.
Yeah, thank you, Lars, for showing where customers could get more information. So what to take with, we explained that there are new high availability scenarios and they could all be addressed with SAP HANA and SAP HANA Scale Out. Have a look at our list at the beginning, which are already supported, which are expected to come in the near future, or maybe are just under testing. If you have other scenarios, you could also request to us, to SUSE, and ask if you could implement such a kind of thing, then it could be made together with you. Demand of disaster recovery and data replication functionality for scale up is already there, and for scale out it will come. It depends on your HANA version. It must at least be HANA 2.0 SPSO3, as you have heard. And for scale out, we will have it in our package 1.180 for SAP 15 SP3 and for all the 15 SPs following up. And we have improvements for the day 2 operations by adding integrations into between the SAP HANA and the cluster by doing more functionality in the HANA DR provider integration. So, and with that, we will thank you for attending this session, and I hope you appreciated it.